It's great to be here with you. I have been in and around this space for a long time, 30 years. My first job was working at a university, and I ran a Mac lab and taught some computer classes and did some other things. And I have benefited so greatly in my own career from being able to learn from other people, and the generosity and just the willingness to help others that I've found in the Mac community I've not found anywhere else in tech, right? So coming to a conference like this is always amazing. It's great to see all of you like continuing on in that same tradition of trying to lift each other up and help each other and share with each other generously in a way that helps us all. So I'm going to talk about MCP a little bit, but I want to start with something else. I have, different various interests. If you've been to some of my other talks previously, like a couple years ago, I did a whole thing on Dungeons and Dragons and other things that I enjoy. But this year, I've really been focused on racing. I enjoy Formula One. I think it's amazing. I've been successful in getting my wife into it as well. So now it's something that we can enjoy together. This is the circuit Gilles Villeneuve here in Montreal. And it's really a pretty exciting track because it's got these long stretches where you can accelerate and go quite fast, and then it moves into tight turns. So the cars go from over 200 miles an hour down to 35 miles an hour in like these hairpin turns. There's one particular hairpin turn here in Montreal. And this is what it looks like from the driver's perspective. Exhilarating, fun, interesting. A lot of the focus, of course, is on the car and the driver. And, I love both. I like the tech, all the engineering that goes into the engines and the changes they've made this year between the balance between the, the gasoline engine and the electric motor and some other changes they made with aerodynamics and all that. It's fun, but I also like the people and the stories and all that. To make all this happen, though, there's a whole team of people that work together to enable the car and driver. So the pit stop is probably a pretty dramatic example of that. So here's Ferrari changing the tires on the car in under 2 seconds, right? That's worth seeing again, right? Such a cool visualization of the kind of team coordination that needs to happen and the speed at which they work. So many things have to be planned in advance and set up in order for the team to work like this. So behind the pit stop, okay, there's another team called a place really that's referred to as the pit wall, where there's a few other people that are involved in the race and coordinating all of this work. So here's another example of the Ferrari team. But the roles that you might be familiar with, the team principal, that's the person in charge. They're calling the shots. They're hiring all the people. They're directing what needs to happen. And they're involved in the discussions around strategy and kind of setting the tone for the team. The strategist, they're the person who's looking at the conditions at the race. What are the other teams doing? What's happening with the weather? Is there rain coming in? Is it heating up? What's happening there? The race engineer is the only person on the team who talks to the car and the driver, right? So they have the role of sitting in the middle and talking to, the pit crew, the other engineers, telemetry from the car, getting info from the strategist, and they're consolidating all of that and relaying the instructions out to the car. This is what needs to happen. You might remember the call like box, right? It's time to come in. Tires are degrading. They're falling apart. Maybe there's, you can see the wear or the striping on the tires, and they need to be changed out or updated, right? They're vulnerable. There's the pit crew, right? That actually has the tools, the wrenches to pull the wheels off and put the new ones on and make sure they're tight. If the front end got damaged, they can pull that off and put a new one on. But all these people work together in concert to make this happen. So, of course, that's a perfect segue to model context protocol, right? So, very similar, right? you might be the team principal. You're the one who's deciding what needs to happen and what the strategy is for the race. And you're using the other people on your team, including some tools, right, to communicate out and direct what happens. In the Apple world, right, the MDM is the race engineer. That's the only tool that's allowed to talk to the device and give it instructions about certain aspects of things like security entitlements, right? Those can only come from MDM. Just like the race engineer is the only one that can talk to the car. So what are some of the things that MCP does? When you ask the MCP interface to do something, it goes through a couple steps. So the first one is discovery. So an MCP server will expose a list of tools. All right, so here's just a couple of cherry-picked examples from the ERU MCP server. So there's a couple tools here: get devices, get device details, get apps, right? And it tells you just a little bit about what's required and it's a bit of contextual information. But this list is pretty condensed and it's fairly short. So it's meant for the MCP to grab the whole list, right, or expose the whole list, rather, to the AI agent that's talking to it. And from this, your AI will build some requirements. Like you could see here, to get device details or to get device apps, it needs a device ID. So it knows already, it infers from this information that it's going to need to get the device ID before it can call on these other tools. So then the next step is it needs to do some reasoning around what tools are exposed and what it can do with those. So now it's going to look at the next layer where it has the full schema for individual tools. And here the description actually is what the AI is using to understand what this tool can do. So the description is, basically human readable, right? But it tells the AI a few important things. You don't necessarily have to write these descriptions in such a way that all of the data types that get returned are explicitly called out in a structured format. The AI can infer what sort of data is going to come back by reasoning on the description. So in this example here, get the apps. All right, it's going to return installed apps. For a device, it's polymorphic, so it's going to be a little bit different depending on the platform, and starts to put together an idea of what sort of data it's going to expect when it calls on this tool. Here's another example. So someone raised the feature request, I guess, yesterday about releasing devices from Apple Business. That's actually an API that we have, right, as MDM vendors, and we don't want it. So, if you all would like to have it, that would be great. We're obviously very concerned about our customers accidentally releasing devices from Apple Business when they remove management. They cease to be our customer and they want to remove management from a device. We don't want them to accidentally remove it from Apple Business as well. So we generally don't expose that API, right? So you can have that one. In the description here of deleting the ADE integration, right, the human being who wrote the description added this warning in there, and that is signal that the AI will look at and reason on, and it will decide on its own to put up confirmation dialogues in the chat to ask you if you really want to do this, because there's some language in the description that suggests that this is a destructive operation and maybe you should be cautious about doing it. So the more detail that you can put into these kinds of descriptions, right, the more useful it will be to the AI. Here's another one. So this is sending the wipe command or the erase command to a device. This one doesn't have the double star warning text in the description because it's not going to remove management from that device. It will, or remove it from management. It will, of course, erase it, but if ADE is set up, right, it will re-enroll. but it still explains what's going to happen. All the data on that device will be erased. And it gives some ideas about what the tool is expecting to receive in that command. So you could set a pin on it in order to firmware lock it. You could save the data plan like in an eSIM for a phone. You could do some other things like return to service, where you're providing a Wi-Fi config profile along with the erase command so that it can immediately rejoin the network and re-enroll as soon as it's done erasing. But that is described here in the service catalog in the tool device. So the MCP server, right, is exposing the list of tools and the descriptions of all of those tools to the AI. The AI consumes those in sections, if you will. So it'll get the list of tools, and then when it decides, well, that tool looks promising to do the thing the user has asked me to do, it will go and read the layer 2 description, but it'll do that in short sections, right? It won't ingest the whole schema of all of the descriptions at once. It'll kind of iterate through to try to find the best tool to accomplish the task the user has asked for. So the structure of the way you do this can be helpful, right, in speeding up the whole process. But generally, like, the descriptions themselves are really critical for the AI to understand what it can do and what it should try in order to get the right result. Whoops, hit the wrong key. So here's just putting this into context again. Get device apps. It's implied in the description, and the AI will infer that get the list of apps, that is just a read operation, right? And there's no change happening in the system or on the device. And erase device, it again infers from the description that this is potentially destructive, there's a change in data, something is happening on device, and also that it needs, in both cases, it needs the device ID first before it can call on this tool. The other thing the MCP server does is it sits in between, right, the tools that are exposed to the AI and the actual API endpoints that are being called. So it is mapping those together so that as the request comes in, it can form the request in the proper way from the input from the AI to retrieve the data from the service that's sitting in front of. Okay, so what would you want to do with this? I'll suggest there's at least 3 levels, maybe, to the kinds of things you could do. One is just simple reports, right? I want to ask a question. I want some data back. I want to use natural language to do it instead of sitting down in the web interface and clicking around to build a report, right? Which, as a as a SaaS company, it's like that is the worst job. That we it's so annoying to have to build a reporting infrastructure, right, for all of your customers, because every customer wants something slightly different. No one likes the interface, and you see it in software tools where the reporting gets more and more complicated over time until eventually you've recreated like a BI tool inside of your own platform, right? And so it's pretty exciting that customers can use the APIs and now the MCP server to ask for the report that they want in the way that they want it. Okay. The second level, if you will, is taking action. Like, I want you to do this thing in the tool. I want you to make this change. I want you to configure something. I want you to add a tag to a device. I want you to send a command. I want you to add library items or configure, make configuration profiles, whatever it is. That's pretty exciting too. And then lastly, integrations. Because the AI has the potential to talk to multiple systems and multiple MCP servers that are attached to different systems. Now the AI can actually work as the integration layer to bring all that data together and show you new and interesting things that weren't possible to do before or were extremely tedious to do by hand. So I hope to actually show you this. I was on the Wi-Fi earlier, and it was working great when everyone was outside in the having breakfast, and then as you all came in, it stopped working. So I've tethered to my phone, and let's fingers crossed hope that this will actually work. So I've had Cloud open, and I was getting ready for this, asked it a few questions. It actually quite likes the MDOYVR conference, and I had nice complimentary things to say about it. It did know about the schedule and reminded me that it was today and that I'm actually speaking at 9:55. So it did a great job of getting some general knowledge information and presenting it to me, but I want to show you a little bit about how it could work with Eru. So I could ask it something like, please. I always try to be polite to the AI just in case, right? Yeah, because it might be handy later to have like a good rep score. So I'm conscious of that. But I could say, please show me a summary of devices. If I spelled that wrong. In let's say one of these test instances, I have Eru jellies by platform. Okay, so hopefully it won't take more than just a few seconds to do this, but obviously in a pretty simple query, I could go to the web interface. I've got it open over here, and look at the list of devices that are in this tenant, and kind of say, oh, okay, I've got count them up. Mac, Windows, Android, etc. But it's already got the answer for me. It's presented in this nice little table that I can use and refer to. So that's kind of nice. That's that first level I was talking about, where hey, I just need some data. I'd like you to go get it for me and present it in a summary, just to save me a little bit of time. I of course, I could go write a Python script that did the same thing, but that would take me a lot more time. So this is a productivity boost. It helps me out a little bit. Another thing that I might be able to do is ask, like how many devices have a vulnerability over, a CVS score of 9, let's say, and now I'm asking it to do kind of a little more complicated thing, right? Where it's going to get a list of all the vulnerabilities on all of the devices that it knows about, and then filter that by ones that are over 9. So it can give me an answer there, and just save me a bit of time again on a little bit of a report that I need. Okay, so it's got one already that it's identified. There's a couple others. But I'll come back to this in a minute when we talk about integrations. So when I want to take an action, we could do an example like, I don't know, please again, send a blank push to Ryan Skater's MacBook Air, and tell me if it succeeded. So the AI at this point is getting that list of tools, right? And it's going through and it's going to find the command tools. And when it goes and looks at the description of those in there, it will find that there is a blank push command that is available. Just all the standard MDM commands are exposed. And it will reason out, okay, this is the tool that I want to use to send the blank push. And it found the serial number, and it's given me back. And it's told me that it succeeded, right? That the command was accepted, and that Eru is saying, yep, command sent, right? But that doesn't really tell me if the command succeeded, right? It just like, the old MDM stuff, it was sent. You don't necessarily know that it was received. So what it can ask me to do now is like, in a previous run, it prompted for this, but I'm going to tell it to do it. Can you check the check-in time to confirm that the push was successful? And so, I was hoping it would follow the same behavior, right? But AIs are non-deterministic. It don't necessarily do the same thing every time. But it, in a previous run, it reasoned out on its own that, hey, just knowing that the command was received isn't the full story. Do you want me to check for the last check-in time to know that it was successful? So sure enough, right, it's now inferred or reasoned out what I want to know, which is that the blank push was sent at a particular time and the last check-in was 6 seconds after that, or 5 seconds after that. Okay, so it's now reasoned out that that indicates success. Kind of cool. Some other things that you can do are, like I said, reporting actions, but you can also do some interesting integrations. So things like, are there any shared device models between Weldon and Jelly? So I've got 2 different instances that are connected with MCP servers, and I'm going to ask it to compare the list of devices in the 2 different tenants and tell me if there's any common models. And sure enough, there are. It found that there's an iPad of the same model type in each one, right? So again, something I could have done on my own, but would have taken a long time, figured out. Let's say something else, like of the, how do I want to ask this question? So of the vulnerabilities on devices in Jellies, can you group those by direct manager found in the CSV? Okay, so this is a little contrived, right? But what I'm trying to show you is that the data about the users is in ERU, right, and the devices that they have, and I'm asking it to find the vulnerabilities. But the info about who their direct manager is not in ERU. Like that field or that attribute of the user didn't come over in the SCIM connection. So it's actually going to a different source to find the direct manager. And now it's going to pull those things together and show me this report where I've got, Homer Simpson is the direct manager for people that have 10 devices that represent this many vulnerabilities, and has the highest CVSS score reported on here, right? So then I can do something like, do I have any upcoming meetings with people that have CVSS scores above 9, right? And it will go out and look at my calendar, right, and the list of people that it's found in this report, and compare those 2 tools together. So waiting until we have a team meeting or some other thing, to discuss the fact that they have specific vulnerabilities or some other issue on their device is probably not the best management technique, right? You might want to take a little more proactive stance on this sort of thing. But again, it's just illustrative of the idea that I can now build an integration essentially between these different systems that doesn't exist before I asked Claude to do it, right? It can compare my calendar with the list of users that have different issues here. Okay, and I could continue to do other more interesting things too. So just previously, I asked it to build a little web dashboard of what's happening with apps. They're being updated from our app catalog, and very quickly just built a report here. I can click around and see a list of devices. I get a donut chart here of the state. So these ones are fully patched. These ones have some pending app updates that need to go out. And this was all built very quickly. I didn't want to take the time to do it directly just because I was worried it might take too long. But there you go. These kinds of things that you could do quite quickly and easily because of that. So some general ideas, scheduling, deciding what tools to call in what order. Just a simple example of the AI infers from the description, I've got to get a device ID before it can ask for details. So it figures out the order it needs to do everything in. But also, if you ask it to do things like compare my calendar against this other list, it figures all that out. The routing piece, this came up with Olivia, right? Talking about the expense that's required with different AI tools if you're using different models. So, being intelligent, being thoughtful about which model to use when you're making the request, because it's going to use more tokens, right, to generate a request or to build an answer for you. So you can do some of that. Apple's done some really interesting things, right, with Apple Intelligence and the way that it's doing the routing to different models, which I think is a good example of the kinds of things we should be thinking about as we're building these tools. So can we put that layer in there to decide, hey, this should go to a local model, that should go to the pro model, that should go to the cloud, and let's make sure we're sending the request to the right place in order to be efficient, but also to save money, and then orchestration across all of these different systems. So MCP, right, is the team radio for IT, right? In order to make all this happen for the pit crew to talk to the pit wall and the team there, and for the principal to relay instructions and the strategist to say what's coming up, the race engineer has to have all that information over a shared channel, right? And that's what MCP does. It allows everybody to put on a headset, get plugged in, and understand what's going on so that information can get moved around and relayed and brought together in a way that hopefully helps the team win together. So we've come to the end, and while I personally was a bit skeptical of AI when it first arrived with like image generation tools and things that I didn't see as being really relevant to my career and my interests, right? This new agentic AI period of time that we're entering, right? And the capabilities that are possible with MCP Server sitting in front of the IT tools that we all love and enjoy and like to use offers a really interesting future for all of us, and something, frankly, I'm pretty excited about, just because I've seen it deliver capabilities that I want to have and things that are useful to me. And I hope you found this of interest as well. So thank you.